right, guys, in this video we are going to talk, that's not working. We're going to talk about simplifying radicals. All right, simplifying radicals, and you guys know the parts of a radical. Let me bump this up a little bit bigger so it's easier to write. Hopefully that's not too big. No, that's good. Okay, so for the parts of a radical, let me zoom in here. You guys know that the symbol, I hope, this symbol is called the radical. But you may not have known that the number underneath and the number where the n is, if there is one, also have names. Where the little n is called the index. And the number that's under the radical is called the radicand. The radicand, okay? If there's no index number, if you only see a radical with a number underneath, we assume that that is a square root, and so we assume that n is equal to 2. If we had a 2 here, that would be the same thing as square root of 4. So when we do square roots, we don't write the index, we just use the radical with the number, okay? Now, if the radical has more than one root, the radical sign indicates only the principal or positive root. What that means is, for example, 2 numbers are square roots of 4, 2 and negative 2. So when they ask you for the square root of 4, how are you supposed to know what answer to put down? If you only have the radical sign by itself, they want the positive number. If they're looking for the negative number, they will put it out front of the radical sign like this. The negative square root of 4 is negative 2. So for all intents and purposes on this paper doing square roots, you are going to have positive answers. All right, take a moment, pause the video, and list the first 12 perfect squares. All right, let's see if you're right. Remember that to find the perfect squares, you multiply the number times itself. 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. And we'll go up to the first 12. Which would be up to 144, okay? So now we're going to simplify these square roots here. Square root of 16, I hope everybody knows that that is 4. 2 square root of 121. Now, with the 2 in front of the square root symbol like this, it means 2 times the square root of 121. So the number in front is a number that you multiply times whatever the answer to your square root is. Well, the square root of 121 is 11, and 2 times 11 is 22. Square root of 289. 289 is a perfect square. It's not on the list because it's higher up in the list past 12, but if you got your calculator out, you would know that the square root of 289 is 17, or if you remembered, your perfect squares all the way up to 400 are the ones you're supposed to have memorized. And 6 times 17 is, I don't know, let's get out the calculator and see. 6 times 17 is 102. And then 3 square root of 400. So we're going to take 3, multiply it times the square root of 400, which is 20. And that gives us 60. Okay. You have, up until this point, been working mostly with perfect squares. So now we're going to see what happens when your number is not a perfect square. You can actually simplify square roots of non-perfect squares. We are not going to follow this system, okay? We find that if students do a factor tree breakdown, it helps them understand much, much better. So I'm going to show you how to do a factor tree to find the square roots of these numbers. Is that a big fat line? Yes, it is. Let me make this a little bit smaller. So let's say, come on, I want you up to 1. There we go. So I've got the square root of 32. What I'm going to do is I'm going to make a factor tree for 32 until I get down to all prime numbers. So what times what makes 32? Well, I know from my multiplication tables that 8 times 4 makes 32. All right. What times what makes 8? I can do 4 times 2. 2 is a prime number. I can't go any farther, but I can break down 4 into 2 times 2. Now, the 4 over here, I can also break down into 2 times 2. So 32 could also be written as 2 times 2 times 2 times 2 times 2. Okay? What we're going to do is we're going to rewrite our radical with 5 2's underneath. Okay? Now, since we're talking about square roots, I can pull out pairs. Think for a second about the square root of 4. That's really the square root of 2 times 2, right? The square root of 4 is 2. I have 2 2's. I could cross them out and turn them into 1 2 outside the radical. Square root of 16 is really the square root of 4 times 4. I've got 2 of them. Take 1 out. That's the answer. Square root of 16 is 4. We're going to do that same thing up here with this 2 times 2 times 2 times 2 times 2 we've got going. I'm going to look for pairs. Since we're doing square roots, that's a number times a number. 2 times 2 is 4, and the square root of 4 is 2. So I'm going to circle 2 2's, cross them out, take 1 out. I have another pair of 2's. 2 times 2 is 4, square root of 4 is 2. So cross them out, take out another one. Now I have 1 2 left. There's nobody to pair it with. So it is going to stay under the radical sign. I'm going to simplify 2 times 2, that's 4. And here is the way we simplify square root of 32. Square root of 32 is 4 square root of 2. Here is the other way that you could look at that if you are really good at your perfect squares or you're good at your multiplication and breaking down numbers. I could also say, okay, 32 is 16 times 2, and I know that 16 is a perfect square and 2 is not. So it would be this, square root of 16 is 4, keep the 2. You could also do it that way. If you are able to break your initial number down into perfect square times something, then you can just take the square root of the perfect square. The other number stays under the radical sign. It's a little bit shorter of a method to do it, but when you get into big numbers, sometimes it's not so easy to see the perfect squares. Whoops. So let me erase this and let's roll over to number 6 and try this method again. We're going to do the factor method. So I want to simplify the square root of 180. So I'm going to make my factor tree for 180. Immediately I'm thinking, if I think to myself, what times what makes 18? I know 9 times 2, so this would be really 9 times 20. Or it could be 90 times 2. No matter how you factor it at the end, it's going to come out to be the same answer. I know that 9 can be broken down into 3 times 3, but 3's can't be broken down any farther. 20 could be 10 times 2. The 2 can't go any further. 10 could be 5 times 2, and neither one of these numbers can go any farther. So now what I want to do is replace the 180 with all of these circled numbers, and I'm going to put the pairs together. So 3 times 3, 2 times 2, and then the 5. Now it's time to take out, we're going to look for pairs and take out the square root. So I have a pair of 3's. 3 times 3 is 9, and the square root of 9 is really 3. 2 times 2 is 4, and the square root of 4 is 2. Notice the dot, I'm multiplying. And I'm left with a 5 by itself. I'm going to keep that under the radical. And now just multiply here. And here's my simplified answer. Okay? 6 square root of 5. Let's look at number, let's see, where did I want to go from here? Let's look at number 7. I have the square root of 147. So I'm going to make a factor tree. And when I first look at 147, I don't have the slightest idea what goes into 147, but I know 2 doesn't because it's not even. I know 5 doesn't because it doesn't end in 5 or 0. And 7s are usually weird kind of numbers. So I decided to start with 3. And on my calculator, I did 147 divided by 3, and that gave me 49. So I know that I could do 49 times 3. 3 is a prime number. We're done right there. 49 I know is 7 times 7, and it turns out that 7 is also a prime number. So this is what we're going to put under our radical. I'm going to keep the pairs together, and now I'm going to simplify. 7 times 7 is 49, square root of 49 is 7, and I have a 3 left. That is my answer. Okay? Let's take a look at one that has a number out front of the radical sign. Take a look at number 10. All right, so remember that 2 square root of 54 means 2 times the square root of 54. So I'm going to use my same method. I'm going to put 54 and I'm going to do the factor tree. I know from my multiplication tables that 54 is 9 times 6. See guys, this is why you need to know your multiplication tables. It makes all this other math so easy. 9 I know can break down into 3 times 3, and those are prime numbers. 6 can break down into 3 times 2, and those are also prime numbers. So I'm going to keep the 2 in the front. I'm going to replace my 54 with 3 times 3 times 3 times 2. I have a pair of 3's that I could take out, but then I have a 3 and a 2 left. I cannot take out the 3 or the 2, so I have to leave those under the radical. So I need to simplify both. 2 times 3 is 6. 3 times 2, also 6. 6 square root of 6 is the answer. Okay. I want to look at one more, and that is number 11, because it has a negative number out in front. That really doesn't make much of a difference though. I'm going to use the same breakdown. I'm going to take my 150 and I'm going to make a factor tree. Ooh, that got really big. Let's go back down to 1. There we go. All right. So I can factor 150. I know that 150 could be 50 times 3. There's one prime number. 50 I know is 25 times 2. There's another prime. 25 is 5 times 5, and there are 2 more primes. So I'm going to keep the negative 5 in the front, replace the 150 with my numbers from my factor tree. Here's a pair right here, so I can pull out a 5, but I can't pull out anything here, so I'm going to keep the 2 times 3. Simplify the front, simplify the radicand, and there you go. So in this case, having a negative in the front just meant that our final answer was negative. Okay, so what I want you guys to do is try on your own numbers, let's see, 8, 9, 12, 13, 14, and when you get done with those, check your answers. Pause the video, please, do those problems, check your answers, and then come back to talk about perfect cubes. All right, so we're back now to talk about cubes and cube roots. So a perfect cube, a perfect square was a number times itself. 1 times 1, 2 times 2, 3 times 3, 4 times 4. Perfect cubes are numbers times themselves 3 times. 1 times 1 times 1. 2 times 2 times 2. 3 times 3 times 3. 4 times 4 times 4. 5 times 5 times 5. 6 times 6 times 6. 7 times 7 times 7. 8 times 8 times 8. 9 times 9 times 9. And 10 times 10 times 10. All right, these are the perfect cubes. When we're finding the cube root, and this is what we call this symbol, when the index is 3, this is called a cube root. And the cube root of 8, I want to know what number times itself 3 times is going to equal to 8. Well, if I go back to my perfect cubes that I just wrote, let's see if I can change colors here. I'll change to pink. All right, remember that this was 1 times 1 times 1. This was 2 times 2 times 2. This was 3 times 3 times 3. I'm going to write myself a little cheat sheet here because it will come in handy. Okay, so looking at this chart, what number times itself 3 times equals 8? Well, that is 2. So the cubed root of 8 is 2. Okay. Number 16, 5 cube root of 543. Well, what is the cube root of, 343? Take a look at the list. It is right here above. The cube root of 343 is 7. So this is really 5 times 7, which is 35. Looking at this one, now this is an interesting one, the negatives. Remember that, let's go back to the previous page. Remember how we talked about that square roots could be positive or negative. It could be positive, for example, square root of 4 could be positive 2 or negative 2, right? And that we needed to see the negative out front, like here, in order to be able to give the negative answer. Cube roots are a little bit different. Whoops, that's not what I wanted. Sorry. Okay. The cube root of 1 could be positive 1 or negative 1. The cube root of 2 could be positive 2. The cube root of 8 rather could be positive 2 or negative 2. Because, the cube root of 8 is positive 2, but the cubed root, I'm getting all over myself here trying to explain. I'm going to use this hole right here. The cube, if I do 2 times 2 times 2, that gives me 8. If I do negative 2 times negative 2 times negative 2, that gives me negative 8, right? A negative times a negative is a positive, times another negative makes a negative. So the answer to the cubed root of 8 would be 2. The cube root of negative 8 would be negative 2. We've been taught up until now that you can't have a negative sign under the radical. But you can if you're talking about cubed roots, because a negative times a negative times a negative, if you multiply a negative 3 times, you do actually get a negative answer. If I were doing square roots, the answer is positive both times, so it's always going to have a 4 underneath, okay? We actually can do the cube root of a negative number. So let me come back down here. Negative 27, well, positive 27 is right here. So if the cube root of 27 is 3, the cube root of negative 27 is negative 3. Multiply it out on the calculator if you're not sure. Negative 3 times negative 3 times negative 3 is indeed negative 27. All right, and looking at number 18, 2 times the cube root of negative 1,000. Well, the cube root of positive 1,000 is 10, so the cube root of negative 1,000 is negative 10. That would give us negative 20. Okay. Let's, in order to do our next problems, let's do the positive ones first, and then I'll come back to the negative ones. All right, so we're looking at the radicand, the number that's under the radical, and we're going to do 19 and 20 and 21, and we're going to come back to number 22, and we will come back to number 23. We'll do number 24. The number in front, I don't really care about. It's the number underneath the radical sign, since that's positive. We can do that one with the same method that we did the square roots. The problems like 22, 23, and 24, or 22 and 23 rather, are really challenge problems that you probably would not see on your SOL. So I'm going to show you how to do it, but this is an extension, something that you did not really need to know. So for the cube root of 40, I'm going to start off with the same method that I did with the square roots. I'm going to do a factor tree. I know that 40 is 10 times 4. 10 can be 5 times 2. These are both prime numbers. And 4 can be 2 times 2, also prime numbers. I'm going to replace, and don't forget the little 3, that's important. I'm going to replace the 40 with my numbers. I'm putting all the like numbers together. Now, since this is cube roots, I'm not going to look for pairs, I'm looking for triplets. Because remember, it has to be a number times itself 3 times. So I have a triplet of 2's, which means I can take a 2 out, and with only the 5 left, it has to stay and there is your answer. Okay, the only difference is you're looking for triplets instead of twins. Let's look at 192. Oh, hey baby, that's my cat. All right, so 192. If I do 192 divided by 2, let's see, 192 divided by 2 is 96. And 96 divided by 2 is 48. And now I get to a number I'm familiar with. I know 6 times 8 is 48. And I can break this down 3 and 2. And I can break this down 4 and 2. And I can break this down 2 and 2. So this is why I like to, you see why I like to circle the primes, so that when it comes time to now go back and rebuild my radical, it's easy for me to see how many I've got. So I want to, remember, I want to bunch them up together by number. So I'm going to put all the 2's first, and I have 1, 2, 3, 4, 5, 6 of them. 1, 2, 3, 4, 5, 6, and the lone 3 right there. Let's go back to blue. And so now again, I'm looking for triplets. So here's a triplet of 2's, take out 1, 2. Here's another triplet of 2's, take out another 2. The poor 3 has to stay all alone. Simplify, and here's your answer. Let's try number 21. I'm going to break down 432. This is going to be 2 times 216. 216 would be 2 times 108. 108 would be 2 times 54. 54, I know from my multiplication tables, is 9 times 6. So I've got a 3 times 3 and a 3 times 2. If you didn't know 9 times 6, you could still keep breaking it down by 2's because it's even numbers. You would eventually end up where I am right now. So I've got a 2 in the front. It's going to stay. I'm going to rewrite my radical. Let me count my 2's. 1, 2, 3, 4. And 1, 2, 3 3's. Keep the 2 in the front. I'm looking for triplets. So here's a triplet of 2's. Here's a triplet of 3's. And I've got a sad little 2 in the middle that has to stay. Simplify the front. 2 times 2 times 3 is 12. 2 times 2 is 4 times 3 makes 12. Cube root of 2. And there's your simplified answer. And we're going to go over to number 24. And we're going to do this one the same way. So 189, let's see, 189, I think numbers that end in 9 are divisible by 3. Sure enough, this is 3 times 63. I know that 7 times 9 is 63. And now I'm down to my prime numbers. I'm going to keep the negative 3 in the front. Replace the radicand with 3 3's and a 7. Here's a triplet. Keep the negative 3 in the front. Take out 1 3 for the triplet. Keep the cubed root of 7. Simplify right here. Negative 9 cubed root of 7. Okay? So that is how you, that's one, I think, pretty good way of simplifying radicals, is to break it down with the factor tree. It helps you to really see easily where the pairs and the triplets are. So if you are ready to go ahead and do the practice page, then I would say go ahead, and if you can print this out, great. If not, just do it on a piece of paper. You're going to do these numbers. I would, if you are not wanting to stretch your brain right now, I would skip these ones at the bottom with the negative radicand, and I would just do all the rest of them. If you're interested in the negative radicand problems, then let's go ahead back up to the top, stay with me, and let's do these 2 that have a negative radicand. Okay. Now, what I want to do with these numbers is I really want to break down this radicand into the perfect cube times a number. I need to know, if I look up here, 250, here we go, 250 is not in this list at the top of the perfect cubes. Could I take one of these perfect cubes and multiply it times something to get 250? Hopefully you can see that if we took 125, whoop, that's not what I intended to do, sorry. If we took 125 times 2, that would give us 250, right? So here's what I want to do. I'm going to know that this is really -2 cubed root of -125 times 2. And I'm putting the -125, I'm putting the negative rather on the 125 and not the 2, because the 125 is a perfect cube. And I know that -5 times -5 times -5 is -125. Because +5 times +5 times +5 is +125, okay? So I can actually jump straight to the cube root of -125, I know is -5, so I can take the -5 out, keep the 2 under the radicand, simplify this, which becomes a +10 cubed root of 2. Okay, instead of breaking down 250 all the way down to primes, I only want to break it down far enough that I can see one of these perfect cube numbers. And I want to attach the negative to the perfect cube. So let's look at number 23. We'll do this one the same way. Okay, so I have -96. Look at these perfect cubes and think to yourself, which one times something would be -96. Think about that for a second. All right. I know that 8 times 12 is 96. So, and 8 is a perfect cube. So what I'm going to do is I'm going to rewrite this as 8 times 12, but I'm going to attach the negative to the -8 because it has to come out to -96. Now, since 8 is a perfect cube, 2 times 2 times 2 equals 8, but -2 times -2 times -2 equals -8, and that's what we've got. So I'm going to take this and I'm going to pull out the -2. The 8 in the front stays. Cube root of 12. 8 times -2 is -16. Cube root of 12. And there you go. That's how you do the negatives. You want to use your perfect cube list, all right, from 1 to 1,000 here, and you want to try to break down your radicand so that you have a perfect cube. Let me change colors here. So you have, like for example, this one, you have a perfect cube times a number. And down here, you have a perfect cube times a number. Attach the negative to the perfect cube and then make the answer to that also negative. That's how you do those. So when you get to the next practice page, you'll be able to do the 3 problems at the bottom. Go ahead and challenge yourself and see how you do with those. All right. I will see you guys next time. We've got one more section to cover in Unit 9, and it is adding, subtracting, multiplying, and dividing radicals. So that will be up next.